just measure here at this side if we have production of CO2. If this happens, that means that we have some methanol arriving here and being reduced. But as I say, this is still an open question. Now you see that if we look at this dark curve here, potential versus current, and in this case we do not have methanol crossover, we will have this behavior. Okay? And remember that the power is the production is the product between the current and voltage. So let's take this point here. With this car, we have about 600 millivolt and 400 milliampere. So the voltage will be 24 watt. But now, if we have methanol crossover, you see that the curves deteriorate consistently. So we have a current loss at the same current. The power will be much less. This is a serious problem. We try then to study, to substitute ethanol with methanol with ethanol, which is better because you can drink this cell, fuel cell. You cannot do it with methanol. So this could be a wine fuel cell. No. Don't do that. In fact, you see, here the fuel is ethanol plus water. It's wine. Okay? Whiskey. What is the name of this Korean drink? Kuku. Suzu. Yes, that's one. Suzu. You can put it. And again, it's the very similar principle. You see that you have here, if everything works correctly, you have here the reduction of ethanol, still producing CO2, because this is obvious, because we have some carbon here. Then also protons, so the protons go through the membrane. This is as the other one, as normal. And then here we have a reduction of oxygen. Again, the structure is the same. We will have the gas diffusion layer, the catalyst layer. So the MEA is the same, as always we did. Of course, also in this case, we have a dual catalyst. But also in this case, we can have not only the transport of protons, but also water and alcohol, which is not good. Same problem. So we'll see what are the applications of the fuel cell. Okay, you see that you remember that we have different types of fuel cell depending on the electrolyte used. So we have the alkaline fuel cell using an alkaline electrolyte, polymer membrane fuel cell, the one we have discussed so far, phosphoric acid, molten carbonate, and solid oxide. And all this maybe work at low temperature, even if 180 is not that low, but certainly this one work at very high temperature. So the application depends on the temperature. You understand that if I want to use a fuel cell for driving a car, I cannot take this one at 800 degrees. Also, the best way of operating the so-called low-temperature fuel cell is using hydrogen fuel. While maybe here we can use methane. Why? Because in this case it's hydrogen the preferred fuel, and hydrogen is produced by, as you know, by reforming of some hydrocarbon. But these temperatures are not too high. Why? In this range the temperature of cell operation is high enough to reform directly or indirectly, as we see, the methane. So while here we have to fill this fuel cell with hydrogen, maybe hydrogen tank. In this case, we can fuel the fuel cell maybe with methane. And the methane will be reformed in the fuel cell itself. And okay, there are some others parameters that rule the application. So, for instance, in this case, we need a cold start because we don't have to reform the methane. So this can be dynamic load application. Dynamic means movable. So this can be, for instance, cars, automobile. This is that constant load application. That means that mostly residential. So in the case of polymer electrolyte fuel cell, you see that we have 3 possible applications. One is on portable, like cellular phones or computers. Not very likely to happen. One is stationary, namely, for instance, for providing electricity in a house. And one is a car. Okay? And these are all the conditions that we need for this type of application. So this, you see, is the first practical application of fuel cell. And this happened at the middle of 70s, where the space missions start to take place. So some were manned shuttle. I mean, there was people inside. Some other were not. In any case, this this shuttle needs some electricity source, and fuel cell was chosen. But you see how I don't have any reference here, but you can still understand how big and huge was this cell. But then, as maybe we already discussed, it came rather clear that a good application of fuel cell is in a car, because a fuel cell car has a series of advantages. Of course, it's environmentally clean, because what the car is producing is only water. And remember that the fuel cell has much higher efficiency than the conventional external combustion engine. And it's more reliable, and it's very comfortable. In fact, I don't know if you ever drove an electric car, but it's very silent and very comfortable. Efficiency we have already discussed. Okay, they also design freedom. It's not that much, because you cannot make, of course, we can shape the car as we like, but it is important that the car is appreciated by the customer. And okay, this is how it works now. You, as I was saying, you have, now it's very easy, because you have this, which is the gas tank, all right? And you start with 100% efficiency, but by the end that you operate all your car, you lost all your heat and everything, you ended up with 12% efficiency. So a lot of waste here. But instead, if we remove, if we remove, where is that? Here. Now we go with an electric engine. Okay, this may be, here is still again indicated as a liquid container. Maybe it could be methanol. But this indicates that here we start with the fuel. So we start with 100%, and we ended up with 30%. So we gain a lot of in energy. And in fact, you see that the efficiency here in terms of percent, and we have various types of engine. In gas or electric, we have 20%, microturbine, 25%, diesel, a little bit better, 30%, but fuel cell is much larger. We can go up to 70%. We discussed that also before. It's very important fuel cell. This is one of the reasons which motivates the interest in fuel cell. And you see, the idea of having a fuel cell car started long ago. It's a famous car which is being produced in 1967 by a professor who is still alive, and I know him very well, he's a friend of mine, Cordish, and he made this car. But was a big thing at the time, but you see how big is the volume occupied by a fuel cell. Because you need a gas tank, you need a gas purifier, and all various things. Now there are other possibilities. This is, for instance, now a power transportation module. So you see that now the fuel cell module is much smaller. This is the car. This is a Ford Focus car. And this is another one. I don't remember where I took this picture, one of these motor show. And then I think, this is another one, a bit curious. I don't think we'll never buy a car like this. And many. But you see, all these fuel cell cars are so far produced only in very small quantities. You know, this is maybe your country car, right? It's Hyundai, Korea, right? Yes, right? So each big car company is having some fuel cell prototype just to show around. Honda, Hyundai, Opel, Ford, this is German, this is American, this is our Japanese, this is German, these are French. But there are not many of these cars on the road. So there's still a lot of problems to be solved. And I think that I show you which are the problems. Right? Cost of the catalyst, cost of the membrane, crossover, or whatever. But here these are reduced. The main problems, one is the cost. And we have to reduce the cost to 50 euro for kilowatt. 50 euro, 5 per 3. 5 per 5, 25, 5 per 1, 75. 50 euro is 75,000 won, right? Can you make this calculation for me? Yes, 1 euro is 1,500 won. So can you multiply 15 by 50? Okay, come on now. It's about, I think it's 75,000. Then, of course, we want that this car is reliable. It appreciates the interest of the 7,500 won, correct? Right, you made the calculation. And, this is another important thing. Remember that we discussed, if you have a fuel cell car, you want this car to operate at least 5 years. And this depends on the lifetime of the fuel cell, which is mostly related to the catalyst deterioration. And then you need infrastructure, because if you use hydrogen as fuel, now you have to refill your car. You need some place where to go and refill your car on the road. This is the other application. This is residential. So you see that here you have some indication. Here you have also now some point of reference. Of course, it depends how big is this pen, but suppose it is normal pen, so you see that module is not that big. And this is mobile, so you can go transport this in various places. Here instead is a unit to furnish electricity to a building. All right, let's discuss about this